Okay, greetings viewers. My name is Bagus Putra Sidharta. Today I will presenting about metallurgies, and for specifically, it's about discovering metals, historical overview. So as you guys can see, this is my profile. For the reference of my presentation today, I took it from the book. It's called Metallurgy for the Non-Metallurgists, the second edition that has been edited by Arthur C. Riordan. And for the main subject, we have 6 points today. It's called first native metals, then the Bronze Age, making metal extractive practice, iron, discovery of modern metals, and refining of metals. So let's talk about the first point. It's native metals. Most metals naturally occur as a mineral or a compounds. The metal atom have react with other metals or with non-metallic atoms. The few metals that are found in an unreacted state are termed native metal. The Chalcolithic period is the name that archaeologists give to the time period that immediately preceded the Bronze Age, in which these metals were first being mastered, and they date this period between approximately 5,000 and 3,000 before centuries. Ancient men first used native or naturally occurring and relatively pure metals such as gold, silver, and copper. Discovery that copper could be obtained by heating cophyllite, malachite, and other bright bluestone or minerals was made between 4,000 and 3,000 before centuries. These were primarily copper sulfide ores. An ore is a natural mineral that can be mined and treated for extraction of any of its components, metallic or otherwise. The observation that metal could be extracted from ores was vital to the development of metallurgies, because the number and supply of native metals was quite limited. Before metallurgy could emerge as an art or science, the ancient metallurgists had to be aware that the supply of raw material was not limited to the native metals. Then let's talk about the Bronze Age. The Bronze Age was the time from around 2000 before centuries to 700 before centuries when people used bronze. The Bronze Age began when it was discovered that mixture of two metal or alloy were stronger than either of the metal taken individually. Bronze was significantly stronger than relative pure copper. A chemical analysis of typical bronze alloy from the ancient Middle East show that the alloy contained approximately 87% copper to 10 to 11 tin and small amount less than 1% of iron, nickel, lead, arsenic, and antimony. That's why bronze can use as a tool and as a weapon. A photograph of an ancient bronze casting is shown in this picture. This casting is example of the high level of perfection achieved in Chinese foundry or technology in the 7th centuries before century. The bronze in this casting contained less tin than was typical of bronze weapons from the same era. As you guys can see in these pictures that has been described. And let's talk about making metal extractive but practical. Most metallic elements occur naturally as a mineral or ores, which are compounds that result from a reaction between metallic and non-metallic atoms. Most copper, zinc, and lead ores are sulfides, while iron and aluminum are generally found in oxide ores. Extraction of metal from their respective ores requires work or energy to separate the metal from the sulfur or oxygen. This energy can be supplied in the form heat, and the first extraction were probably accidental. The extraction of copper, the copper sulfide ores, and from other ore deposit required that the early metallurgists a reaction that had occurred between copper and another element found in the Earth's crust. Melting of copper also resulted in the discovery of alloying and the Bronze Age. The main method of extraction metal are pyrometallurgies, that using heat for making extraction. Then we have hydrometallurgy, that using water, and electrometallurgy, that using electric currents. And let's talk about the pyrometallurgy. The pyrometallurgy is the extraction of metal from ores by chemical reaction at high temperature. In fuel-fired furnace, pyrometallurgy may involve roasting and or smelting for the extraction or refinement of metals. Smelting refers to melting process that separate metal in fused form from non-metallic materials. Hydrometallurgy is leaching or removal of the metal from an ore body by passing a strongly acidic or alkaline solution over the ore. And then let's talk the electrometallurgy. Electrometallurgy involves the extraction of metal from their ore by application of large amount of electrical metallurgies. And then let's talk about this next point is about iron. The early name of iron means stone from heaven. Yeah, iron is stone from heaven in several languages. This name probably resulted because the first iron used by ancient men was literally from heaven. Meteorites weighing from a few ounces of tons have been falling on the earth since its beginning. The meteorites frequently contain a large quantities of metallic iron, and the iron used by ancient men was from this stone from heaven. Iron is a chemical element. The atomic number is 26, and Fe, a Latin ferrum for this symbol. It is a metal that belongs to the first transition series and group 8 of the periodic table. It is by mass the most common element on Earth, forming much of Earth's outer and inner core. And the several types of iron based on their carbon content. Let's talk about the pure iron. Pure iron was a very low carbon content, usually less than 0.03%. It is the purest and softest irons that has known today. And let's talk about wrought iron. Wrought iron has a carbon content of around 2.2. It's 0.02 to 0.08%. This is an iron that has a low carbon content, but it is quite corrosion resistant. Then let's talk about the cast iron. Cast iron has a higher carbon content, usually between 2 to 4%. This is very hard and brittle iron. And let's talk about steel. Steel is iron that contains carbon in the range of 2.2 to 2%. It is the most commonly used iron in the construction of manufacturing. And in the next point, we talk about discovery of modern metals. Modern metals typically refers to metallic material that have been developed or refined using advanced technique and technologies. The metal often possess superior properties such as strength, durability, conductivity, and corrosion resistance compared to the traditional metals. Alloying are generally added to improve the mechanical, electrical, or chemical properties of other metal. Innovation similar to addition of tin to copper to improve strength. Some of the commercial use of several of the metal are described subsequently. Beryllium, or Be, is added to copper to improve its strength. The mechanism or process by which beryllium increase the strength of copper is very different than the strengthening that results by tin or zinc additions to copper. Cadmium was discovered in 1817 and is primarily found in zinc ores. Cadmium coating or plating were used to protect nuts, bolts, and other components made of high-strength steel or other relatively corrosion-prone metals. Chromium improves the resistance of steel to oxidation and corrosion and is an essential ingredient in stainless steel. Chromium was discovered in 1788 and is used mainly as an alloy addition in steel production. Chromium improves the resistance of steel to oxidation and corrosion and is an essential ingredient in stainless steel. Tungsten was first refined from ore 1783 and was originally called wolfranium. Tungsten was first used as the filament or the incandescent light bulb, and this use accounts for 15 to 20% of all the tungsten used. Vanadium is among the hardest of all relatively pure metals. It was discovered in 1830 and is actually more abundant than copper, nickel, or zinc, but is very difficult to purify. Magnesium is the lightest of the widely used structural metal. Magnesium is more than one-third lighter than aluminum. Titanium was discovered about 1790, but because of a difficult freeing titanium from oxygen and nitrogen, it was not readily available as a structural material until the 1940s. Iridium, rhodium, palladium, and platinum are, along with gold, termed the precious metal. They are all very dense and very corrosion resistant. Aluminum, the third most abundant element on the face of the earth, is a member of the family of metal that includes gallium, indium, and thallium. Then, in the end of my presentation, we talk about the refining of metals. Metal refining is an important step in removing continental and other minerals from excavated raw metals. Metal refining methods involve various techniques such as electrolysis, chemical separation, and thermal refining. Refining of metal refers to process that purify extracted metal. Refining of metal, like extraction of metal from ores, included many ancient practices and more modern advances. For example, gold always occurs in a metallic state, and it can be extracted from mineral by relatively simple means. Refining techniques for most metals are much more complicated but involve a similar phenomena. Many techniques now used were not developed until quite recent times. Today, refining can be used to produce very pure metals. Copper, gold, silver, aluminum, iron, and many other metals can be purchased at purity level of 99.9999%, which is equivalent to 1 part impurity in a million. So that's all my presentation for today. Thank you for watching. See you in the next video. Goodbye.